Hi everyone, I am Yogadharani, working as Assistant Professor at Department of Computer Science and Engineering at SNS College of Technology. Today we are going to discuss on important concept in deep learning called representational power. It refers to how well a neural network can learn and represent complex patterns in data. So this concept helps us understand why deep learning works better than traditional net methods, why deeper networks give better performance. So before getting to the topic, there is a small recap of previous videos. Before we let neural network learn pattern from data, layer extracts features step by step, that is in a CNN. Then activation function introduces non-linearity. But the question here is, are all neural network equally powerful? Good. The answer is no. And that is where representational power comes here. And the main objective of this one is to understand representational power, to compare shallow versus deep networks, to learn how deep improves learning. By the end, you guys should be able to explain why deep network perform better on complex data. So see here, when shallow networks are applied to complex data set like images, speech, and text, we may face problems like low accuracy, poor phase separation, weak generalization like that. So here the example here is, a shallow network may fail to distinguish between a cat and a dog because it cannot learn detailed features. So we need models with a higher representational power. The next slide is here. Let's define representational power here is it is ability to model to capture complex relations between data. So think like this, a simple model sees only basic pattern, a powerful model understands deeper structure. Here the real world concept here is, beginners see letters and expert understand full meaning and context. So next come to the ideate slide. To improve representational power, we can increase network depth, use non-linear activation functions, use deep architectures like CNN autoencoders, and improve feature extractions. Here, the example in image recognition, first layer it detects only for edges, second for a nose, face, that is shapes, and then final layer is mainly for whole objects. So as I told in previous videos, that is more layer is equal to more understanding. See here in this slide, we are going to see about what is the difference between shallow network and a deep network. As the number of layers in neural network increases, the model become more powerful in learning complex pattern from data. Here, model learns complex features. In shallow network, the model can learn only simple patterns, but in deeper network, each layer builds on a previous one. And the second main point is accuracy improve. When the model understand feature better, so it makes fewer mistakes. And the third thing is decision boundary becomes better. A deeper network create more complex decision boundaries, and this means the model can separate data points on more effectively, even when the data is higher non-linear. But keep in remember that too much depth without a proper design can create problems. And that first point is overfitting. The model may memorize training data instead of learning general patterns. And then second disadvantage here is training difficulties. Here, very deep network may suffer from issues like vanishing gradient. And then role of non-linearity. Now let's understand a very important concept here is non-linearity in neural networks. Here, non-linearity is introduced using activation functions like ReLO, sigmoid, and tang. So why non-linearity is important? Without non-linearity, if we remove activation function, no matter how many layers we add, the neural network behave like a simple linear model. So with the non-linear, the network can learn complex and non-linear patterns present in the real world data. So how activation function helps? Here, there are three more types of activation functions are here. First one is a ReLU. Because of its performance and its effectiveness, mostly ReLU is used in deep learning concept because it is fast and widely used here. And sigma, its output like a probability, that is, it lies between the 0 to 1. And turn activation function, it keeps that is, it captures both positive and negative values. So these functions introduce curves instead of straight lines, allowing better learning. And the next slide shows the deeper architecture of representational power. Here, deeper architectures are specially designed models that can automatically learn meaningful features from different types of data. And then first one is CNN here. CNN are mainly used for image and spatial data processing. And then RNN for sequence data. Here it is mainly used for sequential data where order matters here. And then autoencoder. Autoencoder is used to learn efficient representation of data. And why these architectures improve representational power is it's automatically learn features. It captures a complex pattern in data. It improves model accuracy more efficiently for specific data types. And this slide shows the mind map of representational power. So this is the application of a representational power. The first application is image classification and object detection and speech recognition system, speech NLP, and model medical diagnostics and image autonomous vehicle and robotics. And this slide shows the summary of today's concept, what we are seeing in representational power. That is a non-linear function. What are the architectures in representational power? Why non-linear is important? How it is used? How it is working in representational power? Likewise, this is the activity one. And thank you, students, for your participation. Students have actively participated and explained concept clearly with a good understanding. Hope guys you understand what is representational power. Catch you in another video. Thank you.